Yeah.
For tomorrow also.
Tomorrow we have to have some small ceremony in
Now I have 1 hour, then will be tea break. I will try to fulfill. Good morning. By the way, Ashwini, did you share the link with students? Okay, perfect. It is just for tutorial free about. It is packed. It's not so big. It is 250 mega, so it is for afternoon. Should I wait or I can start? Okay, perfect. So welcome you everybody for lecture 6. It is almost the last day. Tomorrow will be last day where we take care about mitigations. And today, this lecture, we move from theory and simulation to the measurement chain and the real world field scenarios that I will show you and present you. In my lecture, it will be just example of these measurement scenarios, and during tutorial, I will show you real results. Tomorrow, we will continue with mitigation, and in last tutorial, we will continue how this mitigation algorithm works in reality. So, up to now, we have already discussed how wind turbines generate complex radar clutter and how we can model it in MATLAB. So, but you know that we already also discussed that we need to make validation of our model if it's correct or not correct. And for this, we need to collect the real data measurement, because without this, we can't just make validation if it's right or not. So, today's lecture will be how collect this data outside, what we need to prepare before measurement, and so on and so on. So, first we will describe the practical challenges. Oh, sorry, I am mute. Exactly. Sorry. First, we will describe the practical challenges of field measurement of wind turbine echoes. So, which equipment we need, regulation, site access, what is influence of weather or non-operation states. Then I will show you design of our measurement chain. Of course, you can design own, but we just use this one that is used in measurement campaigns. That includes software-defined radios, antenna, power amplifiers, different type of filters, bandpass filters, control PC, of course some software on this control PC, storage, this hard drive or some SSD drive, and of course power generator, because we are outside, so we need also some power generator. So we first justify choices of frequency band, pulse parameters, because we are make measurement in pulse regime, and selection of waveform, of transmitted waveform for wind turbines radar measurement. I will in detail try explain in few slides what is software defined radios, because I don't know if you are like offline participants experience with these devices. And then I will, at the end of the lecture, I will summarize the key properties of the main measurement scenarios. I will show you for results, it will be locality Kámen, Skalky, Protivanov, it is in Czech Republic, and Grob Schweinbart, it is in Austria, and parameter of the radar settings. And on tutorial, we will continue with this four locations where you will play with real measurement and this measured data. So, what is field test challenges? First, you need to have good equipment that corresponds to your parameter measurement. So, what is which kind of measurement? It will be this SDR radio. It is relatively complex equipment setup. You need relatively big car because the equipment is not small. I talk especially about antennas. From measurement, we don't need only one, measured one scenarios, but multiple one for better validation. So it is exhausting extent of acquired data set, and of course this raw data must be later post-processed, and it is very time consuming manually work. Also before measurement we need to make frequency allocation and utilization, and getting license or permit processing by national authority, it could take a month. It is of course depends on individual country, but generally taking this licensing is not so easy thing. Especially if you will be in some area that is some kindly protected, like airports, close to nuclear power plant, I don't know, or some important object, if you get my point. So of course the transmission around this area or close to borders, it could be relatively tricky. Then we need, of course, make equipment placement inside that we select where we will measure. So it could happen that it's private property, so you need owner permit, airspace compliance, and so on and so on. Or you figure out that you found a really nice place and there is no access road or something. So it is not easy task. You need also, if you will go somewhere for make measurement, you won't do measurement from one place and go back. Usually you you want to plan multiple measurement around one wind turbine to get more and more data, and then it will be more complicated for you. Again, no access road and similar things. Don't forget that for running all this equipment you have electricity and you are outside, so of course that not will be accessible electricity, so you need to definitely get some power generator. And the last but not least thing is weather dependency of measurement. And worst scenario that you will come and wind turbine is static object because there is no wind and you just go back. And imagine that you could get permission of transmission for 1 or 2 days. And if you are really unlucky, 2 days will be no wind and you will not make any measurement and you need to ask for another permission, and so on and so on. So, there is a first use our measurement setup methodology. We designed this measurement chain first, how we say on paper. So we need to know what is required signal to noise ratio, because also you can make a measurement and then you discover that on your measured data is just noise because your reflection is under noise level and you don't see anything. So you also need to know dynamic range of your signal, because if you will be too close, the signal reflection could be so strong that will destroy relatively your SDR, or on other case you need to know if you will be in far away, then you have opposite problem, reflected signal be too low. So dynamic range, what you can expect it is very important, and you could evaluate in advance before measurement. Then next parameter imported is bandwidth. We use about 40 megahertz due to some limitation of SDR, especially for data throughput. And then you need evaluate also storage rate, because if you have higher and higher bandwidth, the storage rate like what megabits per second will be really rapidly increasing, and then you can figure out that even SSD drive is too slow, and you need just think about some different solution how to record this data. Because imagine forget about like data recording about some USB 3.1 or something like this. It is too low, and it is not so stable. So usually this SDR works with LAN, and there is in our software defined radio is 1 gigabit Ethernet and 10 gigabit Ethernet. I recommend you from our experience 10 gigabit Ethernet. But what I can say, it is not so cheap and it is not so usual until now, 10 gigabit Ethernet. So, but it is accessible. So then you determine SDR model, and again it is based on your previous parameters that I already mentioned, antenna gains and sampling frequency. So it is like base parameter. And if you could check my figure, you can see that heart of our measurement chain is software defined radio. Then we have some control PC and storage. It is like hard drive. So of course control PC includes software that controlling this software defined radio and so on. Everything need power supply. Amplifier need little different voltage, so we just put laboratory power supply just for explanation. And then we have transmitting and receiving antenna. Maybe somebody of you can complain, okay, we still talking about radars, one antenna, monostatic solution, and now I have two antennas. Yes, it is quasi monostatic solution, so it is almost monostatic. And why almost? Because transmitting and receiving antenna is like 1 meter far each other. And why we use this? Because we don't need this circulator that for how to say, we don't need switching between transmission and receiving point, but just we make continuous measurement. So we are transmitting and receiving by other antenna. But it is almost like monostatic solution, but there is complete isolation between transmission part and receiving part. So we not need check all this isolation between transmitting, receiving, because we have two antennas. So for us it's like simplification. And why I call it quasi-monostatic, because transmission and receiving antenna is almost in same position, like 1 meter difference, 1.5 meter. If it will be like 100 meter, 50 meter, 1 kilometer, 10 kilometer, then we call it bistatic solution, but it is completely different story. So, okay, two antennas, but it is almost monostatic solution, just for explanation, before you will start complaining. So, also you already discover that our transmitting receiving antenna, there is not any gear, so it is not rotating. Right, we don't use rotation antenna, but what is difference between rotating antenna and non-rotating static antenna? If I will have rotating, that I illuminate my wind turbine only some small period of time. If I have static antenna, that I make illumination for the whole time and get just reflection. It is similar like if you have rotating antenna and always record, always select from the whole one rotation only part. When you make illumination of antenna from each rotation and put like one by one, you will get something similar. Of course, this solution of us will have one big advantage, because when you have rotating antenna and rotating, of course, wind turbine, you don't know and there will be, of course, different some rotation speed. Then you will always illuminate it only part of rotation. But with static antenna, we can see the whole rotation because we are illuminating like the whole time continuously. So you could better discover all these phenomena, all these sinusoids, all these DST component, and all these things. So for this reason, we select this solution. So there is also a big limitation on single shot measurement time that is based on mainly bandwidth and sampling time. And for our measurement, we select about 40 megahertz and sampling rate. I didn't remember. You will saw it later. And it was. We can't increase more, even SDR was able to do it due to limitation of cache size, because then install overloading of this cache and measurements stop working. So first we make measurements like dry verification, when we just interconnect all things and test in our laboratory. Just without measurement of real data, but you need to validate that everything's working. And be sure that on first try, second try, something will be always wrong. So you need really careful test before you go to outside. Then we make outdoor verification, including antennas. It was on closed local site without wind turbines, just for verification. By the way, on this test, we was just on field where we driving just car to show it if we can see changes in Doppler of how like moving the car or something. And again, it was like 3 kilometers, 5 kilometers from university, so it is close. If we forget something, we can go back. If something wrong, we are close to laboratory. So it is like for validation that everything will be set up as we need before real measurement. And then we go to outdoor signal acquisition of wind turbine site. The first site was about 60 kilometers, second site was about 120 kilometers, and Austria it was about 350 kilometers. Believe me, you don't want just figure it out after you drive 350 kilometers that something is wrong and you need go to back without any measurement. So there is some few photos that I found it from labs at testing. This is SDR radio. So you can see just we have uncovered how looks inside. So it is one transmitter. Okay, one is transmitter and one is transmitter and receiver together. So you can use it like 2 channel transmitters or 1 transmitter and 1 receiver. So there is multiple modification how you can use this SDR. And why like this? Because it is just software defined radio. So you are switching how you need. And these blocks you can, okay, this is main board. There you have 1 gigabit, 10 gigabit, that you have RF in, RF out, and so on and so on. And this is like there is under this is FPGA. So you can even process in FPGA if you don't process signals offline in MATLAB. You can directly program FPGA and work there. and this is TXRX and TXRX. 160 is 160 megahertz bandwidth, if I remember well. So it is like classic SDR radio, so it is almost digital device because it is comes from antenna, then some amplification, filtering and AD conversion, and from AD conversion it is just digital processing. Okay, I will open. I just found some okay, it is not in tutorial, it is in lecture. No. Okay, give me a second, I will found it. Picture from our test measurement where was just car. Just check it how looks raw processed outputs. And it is individual time shot of our measurement in like range Doppler map. So you can see there is something what is not moving, static object. It not will be wind turbine, it is just taking measurement. So you can see we make some adoption, and now you can see that there just is some moving object because it is already 10 hertz of Doppler shift, so some cars start moving, just go out from our antennas. Oh, yeah. Some reflection, okay, and it is repetition, so I just want to show you. It is not any, how to say, meaningful, we need just make verification that we will be able to, that their noise is okay, that we will be able to detect moving object and so on. So it is just for testing purpose. Then we make multiple of this kind of measurement. They look little similar, but I will show you. I have 4 of them. Okay, it is similar. You can see there is reflection, movement. I think that there was even 2 cars. It was some spreading of spectra because it was close to field, and there was some agriculture devices or something, if I remember well. So basically, you can see that moving objects are really detected, and we can process with our measurement chain. And I will check next one. I have 4 of them. I think that this is just static. Sorry. Yes, it was, you can see static object, there is nothing else, so it was just, it was reflector, it is corner reflector for antenna, I think, just for static object. And number 4 is also just static object. I will yes, it is also just static object, so not so interesting, so I will continue. There is some few photos from measurement how looks this setup. You can see our both transmission antenna and receiving antenna. You can see that there is some stands. It must be very stable. Be careful, it is about also 20-25 kilo, because this dish is about 1.2 meters. So it is relatively heavy. It is not so easy to carry on. So you need some bigger car, there is control PC, there is some setup, there you can see power generator of course, there is one PC, it is just second PC if we will like backup, there is laboratory, this is amplifier, and this is own SDR radios. So it looks like this, and of course lot of different connectors and like this. And this is from one side, it is from Austria, this is from second side, this is from Protivanov if I remember well. So there was two turbines. But this antenna beam is relatively narrow, so you could just focus to one wind turbine antenna. Even if it's closed, if it looks like very close, so you can focus. So you can see that always you need to place somewhere. There is some small road, but you need outside of road in case of traffic or something. And own measurement, each dataset has from 6 up to 15 seconds, so you make a lot of multiple relatively short measurement, but preparation for measurement, it could take 2 or 3 hours of course if you don't set everything, if you just unload from car and so on and so on. So there is another pictures, but it is just from another view, so you can see how looks this measurement. So what was measurement setup? First I need to told you that we use S-band. It is this software defined radio works in S-band, and it is highly relevant to air traffic control or military air traffic control radars. So you could use this your result with similarity to like radars, like primary radars in air traffic control or this primary radar. So for this reason we use it. We use software defined radio from company National Instruments. You probably all of know you. They are also big developers is LabVIEW environment, but we don't use LabVIEW, we use it only everything in GNU Radio and MATLAB. So what was there? There was also bandwidth pass. Why do you think that we use in receiving antenna bandwidth pass? Because we want to make limitation of noise in specific bandwidth where we make a record. It is just this one reason. Software on Control PC, it was based on Linux. It was Debian version, I didn't remember, but it works generally with any version of Debian. You need carefully install SDR, this National Instrument SDR, because it is, how to say, SDR, it is not typical device like you normally use in PC, plug and play. Forget that you just connect USB or LAN network and everything works. You need install special drivers, set up network connection. Usually you need 2 network cards, because one car for like normal communication when you need set up like download drivers and so on for communication, and second for connection with SDR. And this second one must be, I recommend you 10 gigabits per second network LAN, because you need high bandwidth. So it is based on NISDR drivers connection. It is not only one package, it is multiple package, different package, and you need to install one by one in specific order and so on and so on. So we even spent relatively long time to make like controlling of SDR from Control PC. Even this take you time, and I recommend you just prepare good manual for this. If you already have good setting, just all step that you set, just put to manual for saving your time, because after 2 months, forget that you will remember again. And how was made data acquisition? We don't make record directly in MATLAB. Due to you can connect this software defined radio directly to MATLAB, but there was some small issue about communication delay. And this communication delay caused us problem, so we directly connect to GNU Radio. Do you know GNU Radio? Yes, perfect. So it is free software. I can open link. I just edit today because I was not sure if you know it or not. GNU Radio is like software for controlling any SDR radio that is supported. I don't want to say any, but a lot of them. It is a big advantage that is free completely. It is again community development, and I consider this software one of the best controlling for SDR, and it is very easy to use. All of you know probably MATLAB, but you know that there is also Simulink. It is and Simulink, it is just boxes that you just make interconnection setting and so on. Exactly, this is GNU Radio. So it is perfect for controlling SDR. You can even make the whole signal processing by these toolboxes. And if there is not some toolbox that you need, you can easily make own through Python or different languages, and it is really relatively easy. And I like it. And best thing, it is even free, so why don't use it? And there you have web page of GNU Radio, and I want to see that there is plenty of tutorials how use it, what is it, how installing this national instrument SDR or any different, because some SDR are more simple and just needs USB connection, and this is of course simplification. Maybe you know this SDR, we use it. It not has so high parameter like this national instrument, but it is Pluto SDR and from Adam Pluto, and I can say this is really nice SDR, just connection through USB. Okay, there is some picture. Yes, there is picture. It has receiving, transmitting antenna, and generally you can do it so many things. And price, it is the best thing. Okay, there is block scheme. Price is about, if I am not wrong, $200, $180, $200. So it is not so bad. Of course, you can't make measurement of wind turbines and reflection due to limitation of bandwidth and so on. But for like working, recording a lot of signals, or just visualization of spectra without record of any services, it is really nice devices. We use it a lot of this Adam Pluto for teaching purpose, because you can see, students can see in reality how really works. It is not only in MATLAB. So, and it is full support also of MATLAB, so you just connect and works. So I really recommend you, if you like this area, this is toy for a relatively low price, and you can play for years with this, with different implementation. And a lot of also tutorials for Adam Pluto is in GNU Radio, so even you can't program, you can just open and use it. So for GNU Radio, if you work more maybe in communication, there is a lot of like demodulation techniques, so even you can use DVB demodulation, DAB demodulation, anything, and just listen this radio or something like this. So I recommend you who like this area. This is, and GNU radio is size is similar to mobile phone, only it's like bigger size, but it is nice. I recommend you. I just figure out that I don't told you about this, and it is much cheaper. It is for normal music. Okay, we are back. After data acquisition outside, we made all post-processing offline under MATLAB. You will make lot of how to say data measurement, so post-processing is relatively time-consuming. I don't want to say annoying, time-consuming. And there is justification why we use S-band, because how I already say, it is relevant to air traffic control. It is in range technology limits of our SDR. Our SDR works until approximately 6 gigahertz. So you can see it is relatively high frequencies already. Due to S-band, the size of antenna is reasonably small, and we could use 2 antenna setup, so one dish 1.2 meter. If you will use another band, the antenna can growing up size, and it will be harder to design, and it is output measurement, so you need always transfer this antenna to measurement place, so be careful about this. Also, there is reasonable antenna beam width and contemporary illumination or reflection reception. So this antenna was, how to say, not commercially available, but it was designed just for this measurement, just for this purpose. If I remember well, price was about 2,000 or 3,000 euros, something like this, because it was custom design. We don't make developing of this antenna, we just send requirement which parameter we need, and we send to special company that make for us. And also, you know that you need power amplifier, because SDR output power is very low. You don't have chance to see wind turbines at 2 kilometers, 1.5 kilometers, so on. And you know that you need really high quality amplifier with low noise number, with stable bandwidth, in required bandwidth, and so on, good parameters. And power amplifier in S-band is relatively small and not so expensive. If you will go to higher frequency and higher bandwidth, the price increasing rapidly, so it is another reason, of course, why we use S-band. So, what was decision and trade-offs about our measurement design? Pulse or CV? We use just pulse operation, avoiding contemporary crosstalks, and also it is similar to primary radial pulse system, so we use pulse. You could use design with CV, continuous wave, if you are, or FMCV, it is up to you. Our choice was pulse. Signal modulation, of course, in GNU radio we can, or our SDR, we can program any kind of pulse or pulse compression. It was just function for us, it is not so hard, but we use just unmodulated pulse. Very, very easy implementation, so why don't use it if it's not so important? Timing, pulse length or PRI, it was select based on maximum unambiguous range, you already know it. Blind range, you also already know it. And range coverage relative to blind range and power, transmission power, of course. So based on all these parameters, we make selection of pulse length, this tau, and PRI, one pulse repetition interval. or inverse PRF, so it is same. Antennas has low side lobes, they have good parameters, they support all polarization, so vertical, horizontal, and vertical. So it is mean that in our antennas there was two connections, so we have like connector for vertical, horizontal, and on second vertical, horizontal. So if we will put vertical, transmission, receiving, we have vertical measurement, vertical, horizontal, or horizontal. We could make all this combination. You will see that later that selection of this polarization very influence measure data. But you probably know it very well. Wind turbine scattering is highly anisotropic and polarization dependent, what I already say. So best results was, if I remember well, in horizontal polarization and partially vertical. Cross polarization, it was, you will see, it's almost nothing visible. I will spend 2-3 slides about software-defined radio concept, where the key idea of software radio concept that many radio function which was traditionally implemented like analog in hardware or in hardware, like modulation, demodulation, mixing, filtration, it was moved to software. And for this reason, you want to make conversion to digital signal as soon as possible. And then rest is just math. It is just software defined. It is how MATLAB or something, because output will be IQ data, and then it's just samples. You could play how you want with this. So this I borrow from this link, picture like typical block scheme of SDR. So you can see transmit, receiver, power amplifier, low noise amplifier. Of course you need make power amplifier because you need transmit high power, and receiving power is very low, and you need low noise amplifier to make amplification of received signal to some desired level. And why low noise? No, because you don't want to put another noise source to your received signal. Then is mixer, it is conversion to some lower frequency, and then is ADC converter or opposite DAC converter. So you can see only this is analog, this part. So only amplification and some mixer for conversion to lower frequency. And then is just converters, and from this is all, it is all just digital. And of course there is IQ data, and it is digital baseband, and there you can continue with modulator software processing what you want. It is depend on signal that you are recording, and it is completely correspond to this analog, these two parts, and rest is just digital. It is FPGA, if you can, it is just data. So, digital signal processor, DSP block in software-defined radio function. This is core of the SDR, where the most signal processing task is performed in the digital domain using software and hardware FPGAs. Who knows programming in FPGAs? Is there? Perfect. So you probably have more experience than me, because we are working mainly in MATLAB, so we just use IQ data, but you could implement all this thing directly on SDR and just read outputs. It will be much better for real-time processing, but we don't need real-time processing, so we make post-processing in MATLAB. And of course, and you probably confirm me that programming FPGA is not so easy task, even with some easy functions. So for our one-time measurement setup, or if you don't program devices that will work in real time for a really long time, and it is just for some time measurement, it is not necessary, so we don't use this FPGA and just go to MATLAB. We can discuss later together. For receiver, this DSP processor perform tasks like example interpolation, decimation, digital mixing, demodulation, or other waveform analysis. For transmission, generates baseband signal, performs digital up conversion, prepares signals for transmission. All these signal processing things you could do it on FPGA generally. Then there is user interface application layer. We use GNU Radio. You can use, but also MATLAB, Python. Maybe you have some other ideas which software you can control. We use mainly this three: GNU Radio, MATLAB, Python. I don't know if you use. Okay, LabVIEW, I forgot, of course, it is National Instrument SDR, so LabVIEW is supported. Yeah.
But sir, all the software are paid.
GNU Radio is free, Python is also free.
LabVIEW student version.
And LabVIEW student is also free, I think, but it is just academic licensure, like for student, yeah. And MATLAB, you need to have some site license, but you have site license in IIT, like for academic, yes.
Python
But there, sorry?
Python totally free.
Yeah, and Python. Okay. Octave. It is alternative of MATLAB, and very similar functionality and syntax of. So yeah, Octave. If you don't have MATLAB, you could use Octave. I suppose that will works also very nicely. We have license same like you, so we use MATLAB. And any other software that you think that we can use it for this, like user interface of this SDR? I don't know now. I think that we'll. Scilab. Okay, I don't know it. I will check it later. Thank you.
Like MATLAB.
It is like MATLAB. I will check it. I don't know this alternative because, okay, we have MATLAB the whole time, so I don't need this alternative, but thank you for recommendation. I will check during tea break this one. Okay, we use USRP 2954. There is picture of front and back. So this is front, so you can see it is this one, and from back you can see this one. So there is of course power, 1 gigabit, 10 gigabit Ethernet. Be careful, for 10 gigabit you need like special adapter for connection. Is reference output, reference input, good connection, and we testing it is this with green, how to say, button. It is PCI Express 4, high data bandwidth, but you need of course have on other side also same things. So it is not usually in standard PC. You need probably buy some conversion card or something like this. Or you need to have like hard drive disk from National Instruments. This is this parallelly connected SSD disk together. Yeah. Because we have two of them, about 60 and 80 terabits of data, so we can use it for record. Then there is triggers, in, out, and GPS antenna. There is also, if you need exact location, you could put external GPS antenna. In front, it is JTAG for programming, RF0, it is TXRX, so you can see this connect, you can use it for transmission receiving. This is just receiving, and RF1 transmission receiver again. So it is like, you can use like this for receiving, so like 4 channel, receiving SDR, or you can use it like one transmission and 3 receiving, and so on and so on. And I want to say one thing, I forget, that even if you will buy this one, this part is independent. So even you can use only one UBX160 and this could be empty. So it will be just 2 channel, if you get my point. We have 4 channel, but you can have it like 2 channel. And if something wrong happen with this part, we will just replace this part. But you don't want, of course. This is USRP block diagram. Okay, I will start there. Control PC. 1 gigabit, 10 gigabit connection or PCI Express. Clear, I think. This is some packet routing, and this part is for transmission, and this part is for receiving only. Or this one, not this one, and for transmission and receiving, of course, because you can switch. So there is DAC conversion, low pass filter at 80 megahertz. This is just conversion of phase. This is direct path from 500 megahertz to 6 gigahertz, radio path, transmission amplifier, and go to antenna. Or you can go this way from bandwidth 10 megahertz to 500 megahertz. There is filtration, phase loop lock, and so on and so on, and go to RX2. So generally there is 2 paths, because you can't have it one path from 10 megahertz up to 6 gigahertz. So they have 2 way, like for one bandwidth and second bandwidth. And this is really similar to the first one, only there is 2 receiving parts. So you have low noise amplifier, filtration, direct path, and low bandwidth path, if I can say, drive amplifier, ADC conversion. So there is digital data, receive control, and you gathering data. And of course, this is just valid for USRP. I have block scheme from National Instrument documentation, but generally, a lot of them looks very similar. Different parameters, different filters, and so on, some small differences, but the general point of view will be same. There is some parameters that I will select. I will highlight only some of them. Okay, frequency range from 10 megahertz to 6 gigahertz. It is very impressive. It is very, very high range, and for this, even this price is little increasing, of course. This Adam Pluto that I mentioned, this blue one, small one, it is up to 3 gigahertz. Okay, officially it's up to 1.7. No, it is. It can be software unlocked to higher frequency where it's not officially supported, but works. How to say? Of course, in your responsibility. It was not advice. Okay, instantaneous real-time bandwidth that can process is 160 megahertz. Enough. It is impressive. It is really nice parameter. Maximal IQ sample rate is 200 megasamples per second for transmission in receiving. It is really nice also. Converters, ADC converter is 14 bits and DAC 16 bits. So for small box, nice parameters. The output power is between 17 to 20 dBm, or it is for different bandwidths. You can see RX gain from 0 to 37 dB, maximal input power minus 15 dBm, noise figure of 7 dB, and memory 1 gigabit, and I think that is all. There is some, of course, list of FPGA parameters, but I don't put it because you can read easily manual. It is freely available. So now I have one small question to you. Antenna, you will be probably agree with me, that is type of filter. In which domain work antenna? Time domain, I didn't agree completely.
Spatial domain
Space domain. You missing two more domains. Frequency domain, of course. And we already talked about it. Polarization. Exactly. Yeah. Sorry. You know it. And polarization domain. Exactly. So space, it is narrow beam, isolating single turbine, wide beam, and so on. So it is space domain. Frequency, of course, frequency selectivity. You have designed for specific frequency name. So this was in close to our desired frequency band. And polarization is clear, vertical, horizontal, cross polarization. Perfect. So I will give you few words about transmitting and receiving antenna. We use two of them due to simplification of isolation to avoid needed a high power circulator. It is better for us. So it is quasi monostatic, I already told you. Their company parabolic antenna was JRMC 1200, 2.9, MIMO, multiple input, multiple output, and this is frequency. And 1200, it is mean perimeter of antenna. So you can see how looks like this antenna. Of course, you need two of them, or you need this circulator. And both antennas are same. It is look like transmitting antenna and receiving, but they are same. It is just pair. There you have some parameters from 2.7 to 3.1 gigahertz, gain 28 dB plus minus 1 dB, minus 3 dB beam width, 6.3 degree, port-to-port isolation more than 30 dB, both polarization, it was important for us, and for operating wind load, survival wind load, okay, and antenna weight 42 kilos. There you can see E-plane and H-plane of both antenna, so you can see main lobe and side lobe. How was designed this specific antenna? Sorry. I don't know if you are familiar with, and on axis Y is antenna gain, of course. I don't know if you are familiar with E-plane and H-plane. E-plane is that contains the electric field vector and the main beam, and H-plane contains magnetic field vector. So it is like E-plane elevation pattern, H-plane azimuth pattern. It is like this thing. It is for vertically polarized antenna, and for horizontal it is vice versa, opposite. Then we need power amplifier. This our selection was amplifier from mini circuit ZHL 16 watts and some numbers. You can see the wall amplifier is this one. It is very easy to use, you just connecting, so there is no issue. Range, it has about 10 watts, and it is enough for range coverage. And of course, this power amplifier includes our S-band, so it was suitable. Size, like this one, like this will be 15 centimeters by 15, and this maybe 30 centimeters, something like this. It is not so huge. You can also mount in and so on. Of course, this is amplifier, this is some cooler, so on. So, and it works from 1.8 to 4 gigahertz, and we need 3 gigahertz. Perfect match. There is more multiple option, of course. You could select what do you want. There is typical parameters. I don't think that I need to read it. I just want to put it for you if you are interested. There is signal amplifier characteristics. So it is from datasheet. It is gain, directivity, output power, noise figure in different frequencies, and it is all. Then, if you remember well, there was bandpass filter, and we use this again from mini circuit. It is just small bandpass filter interconnect between this. It is like this one. It is a really small thing. Center frequency was 2.9 megahertz. Passband from 2.7 to 3.1, exactly match to our price. Very low. It is just few euros. It was not expensive. And connector SMA, we usually use SMA connections. There is attenuation of bandpass filter, so you can see exactly in our range there is no attenuation, rest is attenuated. So it is again from datasheet. Additional equipment, we use standard PC, big one, and then we have rugged PC with military specification, because it is, if will start rainy or something, this PC still survive. How to say? And recording device was external hard drive SSD, about 10 terabytes of data. I will not read any data because it is standard laptop, but just in a rugged solution. We have 2 of them for processing, for output measurement mainly. And very important, power supply, power generator. There is not important parameters, it is standards. Oh, and you need, of course, petrol. You can't to forget. And it is all what you need, and a lot of time. So, what? How looks our time?
Yeah. Means time.
Time 40. Okay. So, what do you think if we will make time 40 for 15 minutes or half an hour?
You can.
15 minutes enough? So 15 minutes. Okay. So thank you very much for attention, and we will go for tea. And we have, I think that now today we are on time. We are in half for presentation after Okay, so we will continue. Welcome back after tea break, and we will continue with our lecture. We are still missing 30 samples. So, what is principle of measurement in field? First measurement for sure will be very high amount of measurement data. You need to be very careful about this one, and of course you need carefully plan also timing of measurement. Why? Because you definitely want minimally one rotation of wind turbine, the wall, not only part, because it will be hard to evaluate how to say progression, how it looks like if you have only part of the true rotation. So you need start with nominal wind turbine rotation speed, of course from 0, but it is static object, 1 rpm, 2 rpm, and so on, up to 10, 12, 14 rpm. But 14 rpm will be for some small size wind turbines, because they have higher speed. But for modern one, some bigger one, it will be about 6 up to 8, something like this. So from this rotation parameter you can evaluate time of your measurement. From time of your measurement you could evaluate what is your and from bandwidth you can evaluate some sampling rate, and now you need to fulfill, okay, this sampling rate is adequate and is enough for me or not, and then I need to change the whole hardware to get a higher sampling rate that is supported. So be careful about this. Our measurement, how I already say, is continual measurement with static antennas, so we ignoring the movement of the radar antenna. But it is never mind, we just get response if, but in even our radars that has rotating antenna, usually they have mode without rotation also, of course, because it is, you could set how you need. So this approximates situation of fixed beam sector radar, and it turns our dataset into clean function of blade motion only blade motion, because you want the lowest influence of another reflections, because you want just make analysis of wind turbine reflection. And generally all these things about designing of measurement chain and so on, it is valid for any other measurement. It is not only for wind turbine measurement. Always if you need to make some analysis of some phenomena, just focus to phenomena and try to limit the most other things or artifacts that can influence your measurement. Then it will be much easier for analysis, because it will be just clear phenomena. So for each scenario, it is mean for each place where is wind turbine located, we choose several polarization combination, vertical, vertical, horizontal, horizontal, vertical, horizontal, and so on. Very pulse parameters, so we changing tau to different values. I will present usually always one where was the best measurement of us, where is the phenomena best visible, but made a lot of them with different parameters. Vary pulse parameters, so if it's unmodulated, modulated, and so on. Record multiple bursts at different times to capture variability of wind speed and direction. This could be time demanding, because of course you can spend hours in one measurement place, because if wind not change, then you will still have same or similar results. And try always different position around wind turbine if it is be possible. Because why? Because you choose, you change your angle, and then you can easily see if, and you know already from yesterday analysis, that when I changing your angle, I am changing amplitude of reflection. It is this breathing. So when you are already out, try measure what you can easily say. And always before start of measurement, be sure that your antenna pointing to wind turbine exactly to maximum of antenna beam, because it is also not so easy. If you understand me, you are 1 kilometer, 1.5 kilometer far away, so just be sure that you are looking to exact position. And what I already mentioned, for all setting you need to record metadata. It is crucial, because from IQ data, from raw data, you can't recognize anything. It is IQ samples, nothing you can recognize. You don't know these settings, where you was, what was setting, what was amplification of power amplifier, you don't know. So exact timing, weather conditions, turbine operation state, manual notes, and many other photographs, videos. From video is powerful. You could see a lot of parameters, especially rotation speed, even angle from photo video you could derive in somehow. If you could have it like GPS position of wind turbine is clear, you can find it on map, but record GPS position of your measurement place. It is important. From 2 GPS position you can make derivation of angle, because everything is clear. Oh, we forgot GPS position, and it is really hard to evaluate, because of course you know where you was, so you open map, but it is plus minus 10 meter, 20 meter, there could be some error. Of course, with your GPS measurement there is also error. There is multiple solution. You could use some precise GPS, or you can compare with more GPS devices, because everybody has GPS in mobile, so even if 3 people will be there, you can compare and make some averaging of error, because I don't know, GPS is like when you are using probably navigation, when you go somewhere or something like this, GPS is not much precise. It will be plus minus 10-20 meters, like rough estimation, so it is not quite. I know that on a map show you that you are in right position, but it is just visualization. Don't believe on these values. So without metadata, post-processing after some months becomes very difficult, but I better use it will be impossible. There is setup. You can see that there was some bigger track, because you need to place all this antenna, everything to your track, and there is again, it was ugly weather and almost start raining, so we are placing everything inside track. This is GNU radio example, control PC, SDR, laboratory power supply, there is power amplifier and so on, and there is generator. So there I will put few information about site selection where we make measurement. During tutorial we will play with live demo, we try looking at panorama, you will try looking for some good measurement positions on street view, and so on and so on. So first wind turbine was Vestas V90, coordinates in north and east is this one, so you can easily later add to map and check it where was it measurement. Altitude was 53 meters. Nominal power is 2 megawatts. Rotor diameter is 90 meters. Height of hub is 80 meters. Total weight is 125 meters. So it is mean when this blade will be just in same position like tower, it will be 125 meter. This is just example, how to say, example picture. It is not from place measurement. I will have later this. And there you can see a map. This was main road, very high traffic, so we can't go to this place or this place, if you understand me, because it will be reflection from this wheel, this micro Doppler and all this thing. So there was some agriculture, small road, just go to field, and we measure from this position. It was GPS is this, GPS of wind turbine is this, and this was about 434 meters far away from wind turbines. We call it scenario Kamen because the closest village is named Kamen. By the way, one thing, if I will translate to English, Kamen mean stone. Strange name for village, but it is stone. This Vestas V90 is very common in turbine model in Europe. It's in category smaller one. It is not so big, like average, but it is common. You can see these wind turbines very often close to roads, villages. Be careful and try always select position where you can minimize clutter. And so avoid buildings, barns. Barns is very dangerous. They are very often metal. And imagine that you will have barn there or close. You will get strong reflection from barns because they are very often. Maybe you are looking about weather. It was nice sky, good weather, and it is autumn. Nothing green. It is just before winter, I think end of October or something like this. There was no possibility to see wind turbines without tree lines, but we make, okay, I will explain. This and this, we need pointed just for blades. We don't want this tree, so it is not for instability. It is just it is just correction.
For the stability.
Stability also, of course, but this was for correction, like angle. I forgot to tell you. And I will show you video. Okay. I will show you video even with sound, and then you will understand that measurement was not so comfortable. Power generator, of course. Okay, and now I will again switch off sound and we will run again. So this video, it is just made from a mobile. You don't need anything fancy, of course. But check the blades. From this, I can easily evaluate speed of rotation. Of course, I can zoom it, something, but you can even load to some video editing software for individual frame and really get precise value. Of course, you can just guess or just make some estimation, but video is really nice. It is very good. It is a lot of information. even told you about weather conditions. It is also not bad if you forget. I know that it is multiple time repetition of this, but it is important. It is great source. You will agree, you will work with videos, so you will confirm me. There, what is important is digital elevation model. I already told you, we already discussed yesterday how important is the digital elevation model and what is it. So there is in 3D, it is in MATLAB. There is like in 2D, so you can see that there is almost flat. There is not so big, any valleys, some hills, something between measurement place and wind turbines. By the way, this picture, it is just please, it not completely correspond to ratio. It is just picture, but this elevation profile corrects. There is perfect. This is from street view. It is from SAR, synthetic aperture radar. So you can see that there is field. Of course, there is green. In our is brown because this was captured on maps. It was from different time of the year. So, but you could make easily evaluation. Pardubice is located somewhere here, so it was about 50 kilometers, 60 kilometers far away from us. So, from this information, just based on elevation profile and maps source, and it is not important which map source you will use, we could easily compute slant range from radar to turbine, elevation angle to the hub, and path of the beam above ground. So you can see also what is elevation profile. And all this is crucial for measurement planning. You can just do it before measurement and it is perfect. Of course, you can, how to say, you can arrive to perfect planet measurement place and you can discover there will be some, I don't know, some another new object that is not in a map. It could happen, but you can't do it anything with this. Then there is parameter of the measurement. So sampling frequency was 40 megahertz, PRI was 500 microseconds, it is micro, not U. Pulse length was about 200 nanoseconds, so range resolution around 30 meters. Carrier frequency 3 gigahertz, so you can see exactly S-band. Polarization both vertical, horizontal, and this was testing measurement. It was first time measurement outside of real wind turbine, and it was about 5 seconds, but we made a lot of them, a lot of this measurement. Why only this short? It was just for validation, and second thing, we discovered that we have some problem with this cache overfloating, so next time we plan more carefully, but it is happen, and for this reason we select relatively close site, because always something happen, be sure. And exactly these settings you will use for your simulation, and then produced results must be similar. If not, model has a problem somewhere, of course, or it is not adequately, how to say, it is not with high confidence or something like this. And this is measurement, it is real data, it is not any simulation, it is real measurement of our wind turbines. Of course, there is adaptability of colors. If you will look on raw data, there will be some noise, but we just adjusting like level of colors to be more and more visible. But we don't change data. It is just about visibility. So, what do you think that is this phenomena? How we call it? We have flash. Exactly, flash. It is this where you can't do it anything with this, because it is, of course, there is Doppler frequency and this is time. And always when our signal was completely in phase, each blade element get 100% reflection and hit back to target, and it is this one. So if I will mitigate this in this specific time, I will mitigate everything, even target. Just in this time, it is relatively very narrow. Just ignore this resolution cell, but it is only probably one cell during one time. But check this. Free sine wave. Of course, it is not looks like nicely like from simulation, because there is lot of another reflection. You need have good visualization, I agree, but it is there. It is for one measurement, there is another measurement, and so on and so on. We made about 20 or 30 of them and make comparison of all of them, but it will be very boring if I will show you all of them, because it is just for confirming that works. This is for vertical polarization. Check not only this flash, but even this reflection from blades element that are rotating with lower speed and they are closer to rotor, there is reflection. If you check in horizontal polarization, it not looks like so nicely. This reflection is not so nice at this lower speed. Still you can recognize this sine wave, but it is more and more harder. Why? Because this blade shape is extremely complicated shape. So on horizontal polarization, there is not so many reflection about this one. Then if you compare with vertical polarization, but you don't know it, so make all possible combination of this polarization, and then you will gather the best one. And okay, we don't make we made also cross polarization, but cross polarization, it was the worst results, almost nothing visible. So I even don't put results there. I think that I have in second scenario. Then we go to Skalky Protivanov. It is another site where was another wind turbine. It is RE power MD77, altitude 676 meters, nominal power 1.5 megawatts. You can see it was much bigger wind turbine. Rotor diameter 77 meter, height of hub 85 meters, total weight 123.5. It was close to Protivanov, this village. This is measurement place. This is a location of wind turbine. There was multiple wind turbine. There was one, second, and third, but this third was really small one. It was some like original installation for validation of place or something like this. And now they want to remove this free and install new one, but it is close to weather radar and they didn't get yet permission. Just for information. This picture is just example of this wind turbine in details, but this is example from our measurement. It is against video. So you can see rotation, you can highlight, and if I am not wrong, yeah, both are rotating, and exact location was there. Okay, you can see it. It is just exact location. It looks like in middle of the nowhere. And there you have both wind turbines. So it was about 1 kilometer. And you can see, you can just make, we will play, okay. Still visible, I can show you that we could go like example there. Okay. And later we will play with this one, exactly. And you will help me to find some more position and so on. So, there is presentation of digital elevation model of the scenario. You can see that again relatively flat. There is not any obstacles. Of course, we select position where is no obstacles. We try to plan carefully. So there is viewing from MATLAB where in 3D where is position of radar and wind turbine, and it was about 1 kilometer 900 meters. We made more measurements around more places of wind turbines to get better, more view, more yaw angles. This time the preparation was better, so you can see the time of measurement changes. It is from 5 to 18 seconds. Sampling frequency was same, but PRI is doubled to 400 microseconds. Pulse length is same, 200 nanoseconds. Carrier frequency again 3 gigahertz. Generally, we don't change carrier frequency because it is based on RSDR, so we just measure on still same carrier frequency. And we measure vertical, horizontal, and cross polarization. I remember in scenario 1 we measure generally only vertical, horizontal, but now it was second place measurement and we was a little smarter, so we planned more carefully. And there is result. Okay, this is 5-second measurement. I put it on detail. It is from horizontal polarization. Again, check this one. You still can saw it, but it is not so nicely visible, this sine wave. You know, it is better for, how to say, if you want to fit your measurement with simulated data, generally use flash. Because then when you make like intercover both, you can see that there is it. There is 16-second measurement. Why there is more this? Because it is longer measurements or more flashes occur. And you can see that we are on the edge of Doppler. You can see we are this is maximum of Doppler. And if will be this up to there, then will become there. And we have problem. So it is on the edge. It was also testing if will be it was of course a higher speed of rotation or something like this. There is vertical polarization. measurement. And by the way, I don't mention in all picture, but this red one, this very strong reflection, tower. You can see easily tower always because it static, exactly, zero Doppler. And cross polarization, no. We figure out that cross polarization is not for us because there is almost nothing visible. Okay, you can see these artifacts. There is in this band something, but honestly, free sine wave. You need be really good in guessing. I don't see it. So cross polarization generally we figure out that is not good for us. So vertical, horizontal, okay, but cross polarization, no. Next, it was measurement in Austria. It was really large wind turbines, and it was a close village of Grob Schweinbad. Sorry for my German, I don't speak German. It was one of the biggest wind turbine that is on market. Okay, it is measurement from 2023, so maybe now is some bigger, but generally it is one of the biggest. Vestas 150, there you have location. Oh, sorry, it is Czech, I forgot to translate. It is altitude 250, power 4.2, rotor diameter 150, tower height 166, and Czech. The total length, almost 250 meters. It is really big one. There is detailed picture. It is not our, of course, it is somewhere else, but we don't have access exactly to close to site because it is protected area. There was a lot of wind turbines, so we can go to close. So if I will show you later, I will show you picture from measurement, but it will be small one because we was in a longer distance. There is elevation profile, so you can see we was down, and there start be little tricky. We need be careful to not hit, how to say it, with line of sight ground. But why we don't go there or there or there? It is too big. First time we will be very close, but second time it was protected area. We don't have permission to go there. There was some fence and something like this, because in this area it was about 10 or 20 wind turbines, and they protected and closed it. So you can see that there we have some limitation. It is about 40-50 kilometers far away from Vienna to north, something like this. And elevation profile. And there you can see picture from measurement. So parameters was exactly same like in Protivanov, like in measurement scenarios too, due to reason that for us working in the best way, and we could maximize time of measurement. So if works, don't change it. It is my colleague Beck that is main contributor of mathematical model Karel Jurica. I already mentioned of him, so you don't see him personally, but only his back, but it is him. You can see it was also late autumn, so it was almost winter, not nice, not so nice weather. And there is measurement and check. It is big wind turbines, big reflection, and speed of at end of the blades was very high. And check this, and and this. First time what we see aliasing when aliasing occurs in both like in horizontal, so in vertical polarization. Why occurs? We was relatively close, because of course we must be close because we have some limitation in power, but reflection was higher, and I am just checking, we was about 1 kilometer, yes, 1 kilometer, and the reflection was so strong that aliasing occurs during our measurement. So this will cause exactly your mitigation algorithm big problem. And last scenario that I will present you, it is again from group Schweinbart, but from different position. You can see that there was same parameters of wind turbines, but from different position. Now we was there, and it was about 1.3 kilometers. So we are in far in another position. There is an example of digital elevation model scenario, measurements, and check there was multiple wind turbines. So it is clear why we can go there, because it was protected. There is example of measurement place. It is looks that we measure multiple wind turbines. No, beam was really narrow. Of course, you get some reflection of side lobes, but it was relatively low, so it not so many influence. But we measure this one, not this one, because and check what is angle. It is in a maximal Doppler, because we are just opposite. And it was reason why we want to measure like this, because it is like confirmation. Okay, made measurement from this position. When you have this rotation, you can measure a wall, because it will be just a reflection of static, and you will see only on Doppler 0. So there is nothing. So we want to make measurement, because we was interested, if you are in like this position, the RCS, of course, the speed is high, Doppler, but the reflection area is smaller because you are from this position, and we want just to confirm that if RCS is enough big to show it in our measurement. And how you can see it was nice. And of course check horizontal, vertical, and very, very, very strong aliasing. And I can confirm that it's one of the biggest wind turbines, so I think that the worst scenario, you can't have it about aliasing, because the bigger ones, they are not exist yet, they are planned. I think that in next 3-5 years, about 2030, they plan that they will have maximal height about 300 meters. This is 250, 60, something like this. So you can see that this increasing of size of wind turbine is relatively linear, from 40 meters up to now 300 meters. And cross-polarization results. Not much useful, of course. Only what is visible. You can saw it, this flashes little, but very, very little. So you can see that cross-polarization is not much useful, because they not provide adequate result. And now we will have like live demo. I will show you on maps. First we will check to 2D map. I will hope that everything works, because how is something live? Always something badly happened. It is classic. Oh, this okay, first work. No. Okay. I will open again. Sorry, I will not close it. So it is on Google Map. My system is in Czech, so you can see in Czech, but it is never mind. This is just name of village. So you can see if I will go like this. It is wind turbine Kámen. This is this main road. There is wind turbine. There is wind turbine. You can see it. This is access road to wind turbine, and our measurement was there. And exactly, check this. Something agriculture things there, and you can't, you don't see it on this. So always check satellite map. And of course, it is changing in time. So it is this one. What is most useful is this panorama. Sometimes looks like toy, but check, you can easily watch it. It is look like rotation. You can easily watch it. You can easily plan. Okay, there is trees, because first time we won't go from opposite side, but we unfortunately see we won't go for measurement to this this side, but check, unfortunately, okay, there is visible, you can see, but very small. There was reflection, not good place, so we don't measure on this place. I think that will be same what I already show you now. Yes, it is this. It is just different view if you don't want to spend the time with founding. So yeah, it is this one. So it is this different view. I recommend you use also this mappy.com. It is look that I am advertisement for our site of maps, but it is not exactly true. Please, there you can somewhere switch it to English. It is no issue. Only don't know now where. And what is advantages of this? Okay, I need to check where switch to English. Okay, it was easy. And there is tools. Distance and area measurement. And check. I will select point. And I know, okay, 400 meters. And if I will make click, in same time I see elevation profile. Very useful. Google Maps don't have this feature, so or if they have, I don't know how to use it, because I never found it. So maybe correct me. I don't know. Do you know if is there distance feature in Google Maps? Maybe you have more experience. I really don't know. But this is perfect, because always I can just, okay, quit. I will use measurement again, and from okay, new measurement, and check if I will, oh sorry, new measurement from this, and now I can just check, okay, there is good position, 800 meters, 600 meters, I don't know, 4 kilometers, and so you can easily evaluate place where you want. And always when I make click, show me distance and profile. Just for fun, we can check some place in your country. By the way, in your outside Czech and Slovak Republic, there not will be panorama. I think for sure not will be. So for this reason, I always show both Google Maps worldwide, but for measurement distance you can use it. Our maps, it is okay and it is good. But for street view, unfortunately, you need to use only Google Maps. But I don't, it was about Natham, I think. Okay, but I don't see wind turbines there. But it's possible that our maps use another source and there is not visible. It is another things. Use please more source like this source, Maps Google, Open Street View map, all these three together. Why not? Because it is quickly evaluation, and in all three maybe you have additional information, some more information, because they use different source of this geo object. So is it clear that somewhere could be, somewhere it's not? And this panorama distance, it is, I think, that the same. Yes, it is the same. So it is about manual measurement. I already see you distance, and there we have another example. It was close to Svitavy, and it was there is our wind turbines, two of them, and due to fact that this is very hilly, it was really hard to find place of position, and in 2D maps it is this one. Okay, some truck which we don't want it, and somewhere there sometimes it is really annoying for, yes, can you see it, 1, 2, 3, but sometimes it's hard to find good position, really hard. You need to make coffee or tea or something and spend hours and just finding where is best possible visibility and so on. So it is not easy, especially if you have high density of roads or around buildings or something like this. Sometimes it's really hard to find good position, but it is still better than go there and just driving by car around and found it. So it is still still better. The street view, but I think that will be, yeah, it is this position, so exactly where I was. You can make measurement from this side, and in panorama in our no, I am out. It was somewhere there. Okay, I am in bad position. No, this is some local. You can see it is not easy to find. I will not spend more time on it. But if you can check this distance, what we already prepared, it is about 7 kilometers. It is just example how sometimes could be really hard found good position. And I'm sorry this lecture was a little shorter, it was last slide, so if you have any question, we still have about 15 minutes, something like this, so we can discuss. We could check also OpenStreetMap. This I didn't show you. It is this Janov, but we don't care now about Janov. Okay, there is Protivanov, and Czech, it is this free that I already show you. I will just switch to English. And Czech, I won't get information about this free wind turbines. Okay, and there is information, but just where is position, not any more information. So exactly what I told you, sometimes information could be there, sometimes not. And now is a good example where is no information. So if you don't have any question, it is little shorter, but it is hard to evaluate which lecture will be. It is first time what I have short lecture. Usually I have longer, so I hope that is never mind. Okay, so thank you for your time, and after lunch we will continue with tutorial, if you agree. Okay, thank you. But it is only for 15 minutes, right?
Yeah, we can stop in between or not.
Okay, but I think that will be better if we will continue really after lunch, because it is only 15 minutes difference,
Yeah.
and I will do it only 2 slides and then we will end it. So if never mind if we can't end it now.
Yeah, that's good.
So can we earlier then?
Yeah, that's I am asking. Like in between, to stop these slides is good or not?
Not good. For me, it's better if tutorial is independent, because we will open MATLAB and again continue with all this data.
Then find this.
Okay, thank you very much. Sorry about it, but it is 15 minutes. I do hope that is not so big problem. Please download this tutorial, unpack it, and prepare this folder, because this tutorial free will be a lot of about your work with this map source and so on, because if I know exact position where I should be, so it will be very quick tutorial in this case, but you need to find it.
Yeah, it's okay, it's fine. Noise.
start. So this tutorial 3 will be dependent on previous lecture 5. So some slides will be similar and we'll be discuss it more in details. So we move from purely signal level modeling to a more holistic perspective that combines geospatial analysis with real measurement data, and their whole tutorial is about one question: how do we design, plan and then interpret radar measurements of wind turbines in real terrain? There I have divided the whole task to 3 layers. First is the practical field measurement layer that includes regulation, site access, power supply, weather and all these things. Also fact that wind turbines sometimes didn't operating and so on. Second layer is the system layer. So we need to measurement chain that includes, how we already saw it, SDR platform. Also selection of this SDR platform is very important because it is depends on bandwidth. You can see that we have SDR from 10 megahertz to 6 gigahertz, so it completely fit to our S band. But sometimes could happen that you need to use another band and so on. Data storage, due to high data rate, is also not so easy task. Power amplifier for amplifying of transmitting signal to reach the required unambiguity range, of course. And last but not least is software. You can use a lot of different type of software. How we already saw it, you could control directly from MATLAB. You can also control by GNU Radio. You can also by LabVIEW or any other software that is suitable or that is delivered with your SDR, because of course some developers can give you some software that is already delivered with your SDR. But usually all this SDR, I must say, it is like a universal platform, so working with majority and support majority of this kind of software. And the third layer that is there is geospatial, and it is related to how we use tools like OpenStreetMap, Google Maps, Maps.com, QGIS software, together with digital elevation models for getting information before measurement, like line of sight, clutter. It is mean clutter like buildings, barns, woods, mountains, and anything what could happen during our planning of measurement. And of course visibility of specific turbines. Imagine that if you want to measure only one turbine and you have multiple of them, and you are in position that you are like 2-3 kilometers far away, it could happen that your main beam width not cover only this one that you want to measure, but multiple of them, because you are just too far. So also you need to count all this thing. So by the end of this tutorial, I will show you some specific campaign that we already measured. It will be 3 of them: Kámen, Protivanov and Grobsch Weinbad, and I will present you comparison of simulated and radar and original radar measured outputs. It will be only based on, how to say, comparison of both spectrogram, because it is for best view. It is not, we can also compare individual spectra, but I think that this will be not very useful. So the comparison is based just on of 2 spectrogram, simulated and real one. So by completing this tutorial, you should know, you should have a lot of information how properly select site, how plan your measurement through measurement chain, and so on. For sure, you need be also you need justified choice of frequency band, but this will be related to frequency band that you need to mitigate. So it is mean with radar. It will be weather radar. It is different type of frequency than ATC radar, and so on and so on. It even depends on existing radar system, because each radar works in works in different slight frequency. So it is something like this. And also if you want to use SDR, and I think that is modern devices that offering a lot of positive than negatives, you need to understand little their architecture. With SDR you could make measurement by two different, how to say, approaches. Directly processing on SDR, so you will need to use program this FPGA part that is contains of SDR, or you just make raw measurement of IQ data, and then you need to make somewhere post-processing, and again MATLAB, Octave, and so on and so on. It is your choice. It is nothing mandatory. So this single slide example, like single wind turbine example, is illustrate how we plan this measurement campaign, and it is based on explicitly on a real site. What will be dependency? Which wind turbine you will select? Which wind turbine caused your problems, of course, around your radar. And it could be again two different approach. It could be first approach is that wind turbine is already in environment and influence my already in environment radar, and I need somehow detect what is influence and how to mitigate. Second is that radar is already in position and developers won't develop new wind turbines. And now you need to have our model or different model simulator and make validation, but based only on output from simulator that will not influence your site, your radar site, I mean. And next one is that wind turbines already stand and you want to place radar, and now you need to be careful. Did I choose good position, or it will be influenced by these wind turbines? And I think that is all what I mentioned. It is all this combination. So I suppose now that we have problem that we want to make placement of radar, or radar already is in place, and wind turbine is for us obstacle that reflect signal. So we want to make this measurement. First, what you need consider is wind turbine visibility from place where you want to make a measurement. Usually, of course, if you want to install some radars, you definitely not choose some how to say site that will be like 1 kilometer far away from wind turbines in the same direction where is like your radar looking for targets. It will be nonsense, it is clear. But sometimes even you could be in a longer position and still there is some influence. I just want to highlight that measurement place will be probably always closer than is this radar site. due to fact that whole radar system will have much bigger power than your measurement chain, if you get my point, SDR or this power amplifier. But you could be in the same direction or something like this. So for checking of visibility, we using tools like mappy.com, Google Maps, OpenStreetMaps. I think that these two global services like Google Maps and OpenStreetMaps is the best one. Google Maps and maps.com, they have advantages that there is panorama or street view, clear message. OpenStreetMap, I think that this ability don't have it, or I didn't discover, but I think that this not have it. But OpenStreetMap, they have really big advantages that every object is geospatial object. So very often there is more information about this object, how I already show you in this one example. But it is, how to say, it is like voluntary. It is not mean that there will be all objects. Sometimes you could be lucky and object is here. Sometimes you will be unlucky and object description not will be here. But I don't know if you realize that when I open street maps, if there was missing information about these geo objects, always there is like button add object information. Even you can contribute to this object. So if already know, okay, we make measurements, so you could help other people for next time and you could get this information. And what is very, very important factor is measurement is other clutter sources, and this could be highways, roads with high cloud traffic, because wheels is really great source of Doppler shifting effect due to the rotation of wheels. Trucks, everything could be source of your clutter. So for sure, before your measurement, you need be verified that there is not any this kind of obstacles. And also it is measurement timing, because you know that, as example, in some period of year there is no wind, in some period of year is strong wind, and so on and so on. It is very country by country, so you need carefully plan of all these things. So there is example through mappy.com, where is through panorama visible two turbines, and looks like ideal place for measurement, because just there is not any obstacle and you can see that there is only field, so you will get some reflection from terrain, but definitely there is not any other environment obstacle. So but you need be also careful, because how you can see on this picture, this is road, but also this distance could be so long, range of this distance, that you don't have adequate power for measurement of reflection. Generally any sources that you want to measure, not only wind turbine. So, and now you will have only two options: change place, change amplifier. So of course change place is much cheaper than change amplifier, but sometimes you will need measurement for really exactly place, and then you need redesign your measurement chain and changing. So what is another really important source of maps data is QGIS software. it is free software that where you can download that use OpenStreetMap standardly. So if you will open this software, I will show you later, then you directly see OpenStreetMaps. But just one note, you will see OpenStreetMap if you will be online. If you will be offline, then you can download first requested area manually, and then of course open and add like layer, like one visualization layer to your scenario, and then you can play with it as you want. So I know that everybody almost is online, so there is no issue, but sometimes you need working offline, so be careful about this. It is not automatically. So OpenStreetMap and map.com, even Google Map, it is not picture, it is nothing like this. It is just database of geo objects with different level, with different detail of information. Sometimes there is no information, sometimes is there information. When I check it in our case, close to our measurement place, like this green area, if you will click and get more information, usually show you that is some woods or farming land, village, and so on and so on. And I think that this will be done globally. Of course, I didn't check with all countries, but I think that this info will be always some info available. Also, I warn you about limitation of model, because model of terrain versus reality could be completely different. There is no trees, there is no height of trees, there is no height of building, there is no temporary obstacles. I don't know, parking place where will be 20 trucks, something like this, what is in my mind now. So it could be anything. I know that I'm repeating this for many times, but this will save you a lot of time, and it is always not so easy. Oh, sorry. So this is introduction to OpenStreetMap. How I say, community project, publicly availability, geo object database, presentation on web or through QGIS. So if we will open one more time, there you can see this power plant, and there is a lot of information. If I will check Protivanov place, then you can see that if I will click what is there, sorry, I just switched to English. There is show me that is farmland, that is track, and that is node. And what is node? Just point object. There is no info. If I will go to this one, okay, there is info that is node, name, wind turbine Saint Elias, and okay, it is just name of wind turbines, nothing else. So it is not much helpful, if I can say. Unfortunately, for your measurement, you for sure will need to know what is exact type. But if you can't find it, then it's necessary just go there and check it, or try searching Google and so on. Like in our case, if I will back to original area, we have one side let me check. Yes, we have like this side. I will try switch to English. I hope that they will transfer. Yes, it is like main distributor of energy in Czech Republic, and we have one web page where we have information about all wind turbines that exist in Czech Republic. Maybe something will be similar even in your country, and you can then easily get more information. You need to search. I try it. I didn't find it for your country, because if I will found it, I will show you, of course. I try it, but don't have luck with this. So maybe it's just not translated to English, of course, and I didn't speak Hindi, so my searching is little limited in your local web page. So there is, you can find some information. And now I will talk about Quagis, and I will show you some project. I will not show you, how to say, all details how I already prepared this project, because it is just about setting, how download individual data and so on. I will show you later. So it is for processing any kind of geo object with so many features that I use only really very minority part, because I don't need anything more. But it is, I think, one of the most universal like Quagis software, and it is free. So even if something didn't exist, you could check it on forums, and for sure somebody will help you. So another, it is OpenStreetMap. I already told you this slide only inform you how you should, if you get information and open OpenStreetMaps, then you click to this icon, or you can also okay, I will show you, but for me it's hard, like, okay, and there is, okay, I will again switch to English. Layers, and check, there is different type of layers that you could filter. There is also map tiler, shortbread, humanitarian, cyclo, and so on. You could use it. You could also present if will be overlays, map nodes, map data, and so on and so. So you can see what is differences, which geo object, what is shape of geo object, and so on and so on. Now I will go to Quagis. Quagis is free application, installation size 1.2 gigabits or something like this. It is based on Python. Just give me a second, it is just starting. By the way, working with large amount of data, I of course don't recommend you, even with map sources and so on and so on, I don't recommend you working laptop, but classic PC is better, because sometimes it's very numerically demanding. So I apologize, this is something will take a little longer time. So if you will open QGIS software, you will see this. Oh, sorry. Second screen. You will see this one. You will see this one like this. You can check it the whole world. Okay, my zoom was too rush, and you can zoom what you want, and it is very quick. Of course, depends on your position. And there was wind turbine in Tamil Nadu, but I don't remember which was best, but it is not important. You can see that there you can find all information. But if you want work like offline, or you want to add, how to say, digital elevation profile, because this is just 2D map, how we classically know it. But if you want to add, okay, and now I will go back to Czech because I have downloaded. Oh no, do you see? It is my how to say, digital elevation profile. So white place, it is mean that is flat or valleys. A dark place, it is mean that is we are mountains. So it is the whole Czech Republic. If I will just disable, you can see shape of our, and if I will run it, you can see that it's like approximation of size. Why it is this size? Because each tile, it is like one tile, second tile, third tile, and so on and so on. So you can easily download even the whole your country, the whole world, everything. But it is not small data. I can warn you, so be careful. Originally, it is not looks like this one, but you need press this. Okay, and now I will be little facing problem because my screen is, this screen is too small. Okay, if I will click to, okay, to apply, then you will see original. Okay, get it? This is original data. So it is looks little confusing, if I can say, because we won't make inversion data, because usually valley is white and what is higher it will be dark. So you can use also different visualization, you can choose opacity, you can choose what you want. Honestly, 80%, 90% parameter, I don't know because I don't need them. It is, say, you can say brightness, contrast, saturation, opacity. If you want like to red colors, make change and wind turbines to another colors to be more reflective, just do it. It is just layers. It is just source layers and single band gray, single coral, pseudo color. What do you want? You can play with this like this. So okay, I will invert back because okay, and you can see that visualization is relatively good. Of course, now you see that probably there is some river or something that is something like this, but you have view. Okay, mountains, valleys, and so on and so on. And if you want to see, okay, and where is it? So you can just unclick or change opacity and so on. Okay, but we are focusing on wind turbines, so we will go back to wind turbines. I already pre-download all wind turbines in Czech Republic. So if I will just click this next layer, I see position of all of them. So it could be or not only, because I am pretty sure that this some is also in Poland, some of them probably, or maybe not, maybe it is just on borders, but I can easily check. I will just switch down. Okay, just exactly to borders, like few hundred meters from borders. And why is this useful? You can see, okay, there is 6 of them, 5 of them, and so on. So you can see all this detail. You could adopt for any area that you want in the world, where is available data, of course. It is not mean I didn't found information about actualization of this data, so I don't know how it's solved. But if I can correspond with other websites where is information about wind turbines in Czech, I think that is fidelity is 99%, so probably will be very, very good fidelity on this. So you can see, and just about position of wind turbines. Mountains, there is also mountains, but it is national protected area, so there is no possible. And also mountains, this is very protected area, so there is also mountains, but there is no possible. And we make measurement of this one, it is Kamen, I remember, and then about Svitavy, it is this one. And of course we could also, I don't have it downloaded, but I can show you. Okay, Grob Schweinbad, and there should be location of this wind turbine somewhere close, but I can found it. But this is the village where we make a measurement close to this one. It is strange because there is a lot of them. Location is, no, it is too much. Yes, okay. So it is interesting. I am pretty sure that is this one, and they don't put it to database, probably, because I can recognize the shape when I check it previously before measurement. But I just want to tell you that before you can start, if you want to download manually, you need first install plugins for CRTM downloader. It is sources of data. It is HGDT. It is data publicly available up from NASA websites, but after free registration. Before registration it will not allow you, so you need to have access, and it looks like this. After you install plugin, of course you need put output part where is downloaded and so on, and this is coordinates north, east, west. It is integer number in specific format, which area you want to download, something like this. But I already have downloaded, so I will not download, like one tile about 30-40 megabits. You can even download the whole world, but it will be a lot of terabits, of course, but you can do it. I have links where you can use this downloader, or you can go to directly website and download this CRTM data. So it is just quick visualization that could help to you for determination. Of course, this software also support distance measurement. you can put any other layer information that is possible. By the way, if you will check, there is a lot of tools, intersection, coordinates, raster, and check. I will show you just managing of plugins.
Sir, there is also one function. I'm just asking. It is called view shed. It is if you are on a point, it gives you all the points which are in the line of sight.
For sure, line of sight will be there. Also, plugin. I don't need it because we use it this online tools map.com due to fact that I need this street view and panorama. Because maps are good. It is professional tool for maps processing. I agree, but I need see nature obstacles, and this panorama and street view for me is much better than just watch it to this maps only.
I have good suggestion on it. Let's say I have a wind turbine at a given location. What I will do first, I will find out view shed region. The view shed region will tell me all the points which are in the line of sight. Then I
Yes.
will then I will go to another layer, which is the road layer.
Yeah,
I will see
yeah,
which
yeah.
roads are near.
You can, but it is how to say it is. You could add more layers like this without any problem. I completely agree, but it is relatively complicated. I will just go to my position of wind turbines and surrounding where is like on street view, where is perfect distance, and just watch it directly. And on this I see also all trees, I see also all these things you never will see on a map. So of course, if you will have maybe some military map, maybe there will be more information, but still this open street view, I think that is best, because you know it is like when you are there, it is like video. So imagine that there could be, how I say, some parking place with trucks or something, I don't know, and then you never ever see this how you can use it, this tool. The Quaggy software works with almost any type of geodata types, so geopackage, shapefile, GeoJSON. We will work with GeoJSON. GeoJSON file is JSON, you know probably what is, and GeoJSON is for geographic data. There exists one really nice online web page that allow you filtration based on object that you need. And exactly this red circles where is location of wind turbines, I didn't add manually. I just make a query and get response, export, and it is this GeoJSON format. It also works with databases. It is perfect. Why? Because databases, it is list of objects that I need. There is only one question, if publicly available, yes or not. But again, I think that use this street view is much quicker and better because I see all. Also, it works with web service, so this OpenStreetMap, XYZ tiles, vector tiles, and so on. So it is about Quaggy's tool. How add different type of layer? You will just go to layer, add layer, and you can see that there is a lot of different options what you can add. Vector, raster, mesh, and add XYZ. I just highlight XYZ because this XYZ layer, it is exactly HQ certain data original, so it is for offline processing. You can give this one. Now, how you thought about line of sight? For line of sight, for me, quickest tool is mappy.com, these tools, because I just click to place where I want, click to another place, and completely I see line of sight, even with distance measurement and everything. 2 clicks. So okay, you can use it. QGIS. I probably will use it QGIS so far for more some adventure. If I need more of them, if I need to save this project, if I will reuse project, but if it's for one-time measurement, just use this online tool, and I think that is enough, and it is quick. You can have it in few minutes work done, because you will see distance. From distance, you definitely know maximum distance, because it is limitation of your transmitted power. And in this circle around wind turbine, in this circle limited by your maximum power, you need to find some road that is suitable for you. It is just work, try to find what is best solution. Digital elevation model in 3D or 2D is publicly available based on so-called SRTM dataset. It is space shuttle mission with synthetic aperture radar. Resolution is 90 meters or 30 meters. It is, of course, if you have 30 meters, it is only about the data will be bigger, huge, because there is more information. If you need some higher resolution, then it's not publicly available, or I don't know it. I think that this is maximum resolution that is publicly available. And what is mean? It is also important. It is mean, if resolution is 30 meter, that if you are looking in exact position around is like 30 meter, it is constant. So you don't see the wall shape of terrain. Be careful. Because imagine it is like tile 30 meter by centimeter with some elevation, and next tiles will be different elevation, but still constant 30 meter by 30 meter. So it is mean that in case that there will be some -5 meter valleys in these tiles, you can't saw it because you don't have enough resolution. So I recommend you this resolution. 90 meters, it could be tricky. 100 meters is not short distance. And it could be some terrain inaccuracy, something like this. So line of sight, do you understand me? Okay, of course, you always can move like 100 meters left, right. But maybe you can, because it will be only one road and there will be some houses or something like this. So it is not infinity accuracy. It is just 30 meters or 90 meters. More about this shuttle radar topography mission, you can find it, of course, on Wikipedia. It is just information. It is almost on the whole world except north and south part. No, there is not so many people, of course, and it is some limitation of SAR satellites where they discovering. So it is interesting. There is also principle how they measure versioning and so on and so on. This different, how to say, relief, it is just different interpretation in color and so on. So QGIS, everything will handle it if you need it. But I needed so very low information from QGIS that we don't need it, this one. So you can check, it is nice one. All these data are available only upon registration on NASA site. Later I will have their link. So CRTM, okay, there is CRTM downloader uses this style. So size of one tile is 1 degree, 0.1 degree, and it is north-south latitude, east-west longitude. So how I showed you in this plugin already. Certain data, you can work with them online, offline, and be careful. There are two differences also. We have above mean sea level or above ground level, because usually we use this one, but there exist two types, ground level and sea level, but usually sea level is 0, of course, so we use this one. But it could be even two different type of data, and it will be little differences. So you will add layer X, Y, Z and install this downloader, and if you want to try it, you need set a format of geodata to this WGS84 EPSG, this one, and it is this integer value that you need to put. If you want to download the whole Czechia, you need to put this one, and this is list of data. I don't know if you can read it. It is N48E015, N49E016, N49, and so on and so on. So it is north-east coordinates. It is like the numbering of these tails. If you will open for downloading automatically on Quagis, you need to make a registration. When you open first time this plugin, it will ask you, please log in. If you don't have registration, just click to this link and make registration through email. You will get a confirmation email, you will just approve it, that is confirmed, and it is done. And you will put login credentials, so it is easy. Or there exist even, how to say, online repositories, and you can see each this tile, it is one file. So this is the whole Czech Republic. About 25 megabits about this one tile. Of course, there is, I don't know, approximately 20, 30 of them, something like this. So it is about 1.5 giga or something like this data, or maybe not 100, no, 800 megabits. You already have it in my tutorial free, so you can play it in Quagis. It is in shared file. And this, I found for you these two links. Okay, give me a second. Where is my presentation? Oh, there is. Okay, this first link is for making registration, because if you want to try search for Google and put this certain NASA login registration, it is a lot of web page, and it is hard to find to write one due to link. But I want to show you this one. It is repository, and check. If I will open, you can just download what you want. Just you need to know coordinate that you need. So you can use, like example, JDownloader or something. Just put to link and automatically download 100 of them in a row or something. So it is just up to you. Each tile is in zip. You don't need to unzip. Quag is working also with this zip file, so do it automatically instead you. So just if you understand me, if you download 100, 150 files, so if you don't do it some manually or something, just ignore it and just add layer XYZ, put this file to like drag and drop only, and it will be visible, this one. So it is this, okay, I lost mouse again. So you can see it is divided to different categories. Of course, depends on location, which tile do you need, but it is not so problem to get this information because you click just to place that you want and check coordinates, and then you know which tile you need to search. If you want to work with MATLAB with these tiles, it's possible. If you need to work with tiles one by one, then it's easy. If you need put together multiple one, you need to be careful because of course we are in MATLAB, so it is matrix. And there is little, how to say, overlapping of these tiles. So you need to be careful how you overlap to get exactly right bigger area. And I didn't found it how do it automatically because overlapping is sometimes a little like jittering. So we usually do it manually, but you don't need to process the whole word, how I say you. So usually you need only one tile, maximum 2 tiles. So it is not so problem to do it. But from this link is interesting that of course there from this repository you can even download without any registration. But if you want to download through QGIS plugin, you need to have registration because they use original data and this is just repository. I know that exists minimally 3 or 4 repositories on different places, so it is just one of them, and you could just play it with this if you want, if you wish. Yes, there is just this data, just description of the data and how to add to QGIS, but I already told you. So I will continue. This is opacity color. We already do it this one. Now, imagine that you want just make filtration of object of your interest, not only wind turbine, but any kind of object that you are interested in, any map sources. Like it is based on OpenStreetMap, and Overpass Turbo is available like only online tool. It is web front end for the Overpass API that lets you search, visualize and export OpenStreetMap data with custom queries, and it is perfect. Look, I made one query about Tamil Nadu, about wind turbines, and it showed me all Tamil Nadu all wind turbines in Tamil Nadu area, and it is just there is example of this query. It is based on JSON. There is also of course manual, so you can easily, if you understand JSON format, you can easily find all this information. But generally it is out JSON, definition of area, name Tamil Nadu, boundary administrative, and now node power, generator source wind, power wind turbine, power generator source wind, and like this. And if you just copy and paste this to window, I will show you on Overpass, you will get this selection. But you could also make roads selection, you can make buildings, and so on and so on, but depends only on data that are available on OpenStreetMaps. If something is not in OpenStreetMap, then you will not find it. So of course it is depends if every building or what are you searching is already in OpenStreetMap. It is just searching engine for the geodatabase object, because you definitely don't want to search it one by one, especially for wind turbines in your areas, because I will open now and you will saw it that there is a lot of them. And when you click to any point that you make already, it is filter. It is nothing else. It is just filter. And it exists only on online tools. I think that there not definitely exists offline variant, of course, because you will need all whole world with whole geo object, and there show you some base information. And again, among this information depends how many information is already in OpenStreetMaps. I can't tell you if is there or not, or is not there. So you can see wind turbine wind horizontal axis. Okay, it is classic wind turbine. And exact coordination. It could be useful. Exact coordination. So So when you open this, okay, sorry, where is, okay, we'll switch to English, this is automatically. You can see, you will see like this, it is OpenStreetMap, so nothing happened. I don't know why. Okay, I will go with manually. It is classic OpenStreetMap, and now there you just need to put in JSON format query that you want to. I already have prepared. Sorry, I always lost my. There is my query for Czechia, for the whole Czech Republic, and you can see it is my individual queries that I already check for the whole Czech Republic. So it is GeoJSON. It is exported information. Okay, it is already exported. But query is there, so let me switch presentation, and I will just copy. Okay. I hope that will works. Like this one. Okay, did you see this one? And I will click just run. Sometimes there is error, just press it next time. Sometimes exactly. But I am on Eduram. Sometimes I don't know, you will get this error because the answer takes so long that he will refuse. I think that is deals with if you use VPN or something, because I know that even in Eduram in Czech Republic sometimes I have problem when I try it at home in my, oh okay, You can see now on second time why taking so long time. It is the whole Tamil Nadu region, so be careful if you. Honestly, I try that I will show you all wind turbines in India. After 15 minutes of work still continue, so I was not sure if it works or not. It was too big area, so then I made limitation. So he just told me that this large amount of data, about 3 megabits, continue anyway. He will work now, but I don't want, how to say, I won't save your time. So after is results presented, then you will just click to export, and there is Tamil Nadu export GeoJSON, and you can see this is one wind turbine, this is second wind turbine, and so on and so on and so on and so on. So easily you can see that working without problem. But sometimes you need to click 2 or 3 times. Don't ask me why, but always works. But sometimes, so check, it is one node, second node, third node, and what is there? ID of node, wind turbine, wind, horizontal axis. So it is generator method, generator source, generator type, power generator, and this is just coordinates. It is just filtration, but save your time. Imagine that you have some long range radar and you want in the whole specific area. Just run query and check, okay, there is 10 wind turbines, but they are low, high or something, and you could just make easily get information if should be the problem or is it without problem with your radar. And this directly, this file, just drag and drop and put QGIS, and you will see these individual points in my layer, in my new layer. And it is so easy, so you need just this online tool. And again, advantage, it is free. So only one thing that we are not working, what is not free, is MATLAB in my case, if you get my point. And we could replace it, even this. So it is export, and when you click to export, there is no only GeoJSON format, but lot of them. Just choose GeoJSON because it is compatible with QGIS. There you have area that is defined for filtration of Czech Republic. So it is this. If you will do it this, it is exactly this query that you need to put to overpass.eu, and you will get all these answers. Okay, and this is output of format. So you can see export, you could be GeoJSON, CSV, XML, and so on and so on. So it is up to you. Okay, now we will move to selection of site. I already present you where we made measurement of this site Kamen. But now it will be your task, found minimally 2 other places where we could make a measurement. So, please, found go to this position. Okay, can you see? Go to this position and found me in a circle of 2.5 kilometers, 2 other places that will suitable for measurement. You don't need count power anything because I already told you 2.5 kilometers. So it is clear that power will be adequate. Try found me position. And now you will start working. And please, on the check this. There's just switch to English. And check this. Do you see this eye? It is panorama, and where is red, it is mean that you can click and it will be open street view. So, on the write down, check, switch to English and go to this one. And also you need to be sure that you are in circle 2.5 kilometers. So, please, tools. And where is it? Okay, I am now in exact position. So, tools and measurement. Oh, there, distance and area measurement. So you just click 2 times and you can check it. So try found it. Is it clear that you can only check street view? Where is this red one? It is coverage. Why is those, if I will open, why there is not coverage of this one or this one? Because it is very, very small road. Usually with this road with like dashed or this one, it is just like even not for car, if you understand me, for walking or some between 2 fields or something. Because this map in Czech, they are really detailed, and even you can turn outdoor. I use always outdoor because there is most information. So, who will be first that found some good position where we can make a measurement? If you need any help, just let me know. I can go to your laptop and help you. We made measurement just from this place. Look, there is a wind turbine, and we was there. There. Did you found it? It is this one? No. Can I check?
This is good.
Yes, but you are in road. Can you imagine that you are in main road with your equipment? It is good position.
So we can just go to this position, like this grass here.
Can we go? But probably not. It is hard to see, but there will be some reef for water. So try found where will be road. Not like this is main road. So try another one. Of course, always will be close the road. I agree. Okay, I will make simplification. Be careful, this is the main road. You don't want to stay on main road. So, I will help you. Try check this. This really small one, like maybe there, because it is coincidence. I don't know this place. It is just it is just pure luck. Don't worry. Only I will have little worries for sure that you will see, but it will be static. Okay, so try found another one without pole. I don't know. Maybe didn't exist. Be careful. I don't know. I would like you could try this side or this side, because and also check for me distance. Okay, we are 1 kilometer, it's not bad. 1 kilometer, but I am not sure there, because this and this I am not sure. We will check. I really don't know, because of course we founded this place and make measurement from this, so there is definitely no one good answer. There will be multiple good answer. Found it? We can check this one. Okay, and measurement, quite. Oh, yeah. So maybe. Reflection from terrain. It is up. This. Okay, is line of sight. It is visible. I agree. But I don't much like it. So probably we can check this one, how I already told you. Yes, it is really small one. Okay, I will. I don't know, it is extremely slow. Maybe you will find some gap between trees, but also didn't looks. Oh yeah. Check. And of course you can go to this side. Yeah, it is really nice position also. Check please just distance to wind turbines from this position and tell me. But this is good position. Even this forest will don't affect you so much, because you will make some adjustment of angle of main
700 meter almost.
700. So this was about 500, similar, good. It is just opposite. It is perfect. And imagine now you this. Never mind, because you will make adjustment of angle little. It's possible, because there is a lot of space, I think. Of course, it is still picture. It is you will see on place, but from my point of view, we will make there just test measurement. So for us was enough one measurement, if you get my point, just that our measurement change working. So we was there, but if we really need more position, why not this two? And maybe I will use even this one, but it is, I think, please check 1.3, 1.5 kilometers. It will be a little far, like from this position to wind turbine.
800 to 900 meters.
Okay, okay, okay. So it is little far, but why not? So you can see on this side we found without any problem free position. Okay, please try on this side, and then I will give you one really complicated side. One more. We still have time, so good. Coordinates is there, so just place coordinates. Can I open map? Do you have coordinates? I need to click back quickly because I was already in good position of measurement. And how many of wind turbine is there in this area? Three? Exactly. And found me for position good this one, the first one, and this one. We measure only this one because I think that this and this didn't working. This is small one, I think. Older one, oldest one from this three, and this is too modern. Oh, this will be a little tricky. Let me check. Can you, yeah, okay, this is small one. Can you check? This looks small one. But this is good position. Okay, check this one. Second one, it is relatively good position. Okay, and oh, I even have fear that we are too close.
Can I get the coordinates once again?
Yeah, of course. There is coordinates. Okay. No, check it from this side where I am close to Protivanov, close to village. It is go to hell. There is some obstacles. No, this one not. Maybe this one. Okay, it is the small one. You can see it is really small one. This, when you comparison with this will be about, I don't know, 5-6 meters. So it is some really old one, small one. So you don't want measure this one probably. So we want to measure this one. Yeah, yeah. And it is also okay. Do you want help? You
Where is the panorama option? I have not.
this.
No, I checked. I did this.
Yeah, and click. Right, left. This to this red one.
Yeah, I'm clicking on it.
But to red one, it not change. Ah, okay. Close it because you are in still in wind turbine. Just close it. Why everybody?
This is showing, but I know if I do this, it will show.
Okay.
It okay.
Yeah, and click.
Okay, nice.
You was probably too much in detail. I don't know. I never saw it. This one. Okay.
Okay, no problem. I got it.
Yeah.
I got it.
So there are three view in the center from this position.
Look.
We can see three wind turbines from this position.
Probably you won't measure one of them, but it is okay because you have narrow beam width. So yeah. Exactly. I found same. Yeah. I found second one, this one there, and if you will move, no, opposite side, and this one, and from this position, yeah.
So will this electricity wires cause disturbance?
I think that not. Imagine that electricity, like diameter will be something like this. It is under resolution of your radar. This pole, yes, little, but you will check this one. But this is the oldest one, the small one. Like I might guess 15 meters, 17 meters up to a really small one. So probably you want these two of them. It is new installation, I know. But good. No, I don't want this one. And now I have for last site. Try where is location? I am. Okay, you have their location, just put it these numbers, just these numbers. Oh, sorry. And try this side, last one. And honestly, I tried it and I hardly found any. Maybe you will have more luck. Try it. It is really complicated terrain. If you can check, if you can check it, this is hill, so you go down. It is very hilly. It is on mountains. There you have some limit. There you have some roads, of course. There you can't measure because you are too close. There is hill, so it is too far. I think that there is almost impossible found some relative close place, and everywhere woods. Just try it. Maybe you will have luck, because we planned that we will go there also, but then we don't go. And wait, just put this one, Anenska Studanka, and you don't need to rewrite the whole coordinates. Anenska Studanka. Okay, and when you click to this place, you will see this one, of course. And now check my, I will zoom it, and it is just closed, this one, how you can see. So just run panorama and try it. This is not much suitable, honestly, close to this one, because you will see definitely multiple of them, minimally 3.
This is just below. This is just below.
No, this is not easy site.
Like, are we too close to this one?
I think yes, for
We
sure.
should be. We should go.
No, yeah, you need to go far, but problem is that there is wood. I know. I told you I play with this site maybe 15 minutes. Still also think, no, it is not easy. And imagine, we don't have so big mountains like this, but you have relatively complicated area in a lot of places. So site selection, it's not easy task. Okay, we have last half an hour, so we will continue. If never mind, you can play it later, because I will share this PDF with you, so all links will be available for you. Now I won't present you this digital elevation model. I already told you this is there is original function that we using for reading HGT data that you already downloaded, or I already show you. If you will open this, okay, this is for just function in, okay, India. Yeah, it is MATLAB Central. And when you we use this function. We are not original author of this function because it was available. It is, I think, relatively old function. Okay, it is updated in 2021, but definitely I use it many years, so it is older function. Maybe just a version of MATLAB or something like this. It is very easy usage of this function, and there also, okay, and there you have another download link. It is not, don't worry, I don't know why, but we need to do it just this one. Before 2 days working normally, of course, it is. Okay. and when you open any I don't know what oh sorry, my laptop is tired, looks. Oh, and can you see when you open this, you see again a lot of this data, yes. It is original NASA data, but from different perspective, different views, and so okay, this is JPEG. But in some directory is of course also this HGT data. But I think the two repositories that I already show you, they are better. Okay, please open MATLAB and open profile tutorial. And you will see very simple function that use this read AGT data, and if you run it, you will see just 3D space that you can use. It is just matrix in grids. So you could evaluate line of sight because you need it. And computation of line of sight, it is not so easy as it looks like. It is easy, but imagine that you have radar there in this point, and now you need to compute line of sight in area like 50 kilometers. Do you see how many points is there? Like cross section in grid, and you need to compute line of sight to each of them for coverage area. And imagine that you have area 50 kilometers with a resolution 30 meters. It is a lot of points. And you definitely can use it like by dumpy way, that you will just check one grid by one in some cycle. Good luck. After a few days you will get a result. Computation of line of sight is easy equation. It is just easy. But if you want to do it in the biggest area, you need really high optimization. I am looking at you because you like optimization. So optimization of line of sight, it is not exactly easy task. We made one optimization that was relatively quick, but definitely I don't think optimal that there will be exist lot of much better ways. But you get it. I just show you how you can import this AGT file to matrix and working like matrix. And what is inside matrix? Just elevation of profile in each grid. So you can, and what is this air and this wind turbine? It is just various positioning of wind turbine and radar. And why my wind turbine is on the space, how I can say it? Because you need set correspond height of wind turbine. It is just for visualization. What is important is that this data, where you read HGT, it is your metrics for computation of line of sight. Only one disadvantage is that you can read only one tile. If you need multiple tile, before you will place multiple tile, you need to make this connection of individual tiles to one big tile and then read it. It is only this thing that you need to do it before, because we don't make optimization for multiple automatic tiling, because we don't need it, because it was enough for us, one tile. But principally same, of course. And now we go finally for comparison of model. By the way, I think that there, please, you can see wind turbine time Doppler demo. I can't to show you, it is with Guy, but my laptop is too weak to present this application. Works perfectly on my big computer, but not on this computer. But it is, there is description of individual scenarios, so just please try it on your PC. I unfortunately I tried before 1 hour, then we start, and on my laptop didn't work. But I know that working in normal PC with more power. Because there we play, I will show you the comparison of two localities. It will be again locality Kámen and Protivanov. I always show you same because you are familiar already with this site, and we will make two comparison. Of course, when you see original data, it is this one, and when you open comparison Kámen, this slide, there you will see, give me a second. Don't worry, it is for purpose why I hidden. Just 1 second, I just run it with different values, because I already set good values, and now your task will be found good values. So for this reason, I quickly hidden. It is loading pre-process original data, so it is not so quick. Okay, check. And you told me, what? It is the same? No, it is not same. Why? Because in simulator you have badly data. So your task, speed of wind, initialization angle. Try tweak this, and frequency rotation is speed, and just tweak it, and also nacelle yaw angle. Tweak this skill, tweak these two parameters. Just please, initialization angle, just leave it. Just parameter, this one. Just try to find this and this right answer. Who will be closer? These two values. It is just up to you. And for this reason, I quickly move away, because I already have a good one. And of course, I was in advance, because frequency, I already know it. Why? Because I have video. Yes, so, okay. It will be something between 8 up to 12. But your angle, try to adopt to get the best result for comparison. if I can recommend you, first I will try tweak frequency rotation and how you can recognize amplitude. This should be similar, because quicker rotation speed, higher Doppler. Of course, I will show you results. Okay, I check it. I already put back good values. It is something like this. Okay, I have exact precise value because we check it from videos on the frame, so it was really plus minus, really small error only. And angle, your angle is about 120 degrees. And if you will run it, but took times, I don't know, maybe it's quicker on your PC. Because you need to handle with original data and make computation, of course, based on this simulator. So it took time. And check this if you can. It is exactly 1 second, third one. This gap is this gap. This amplitude is this amplitude, this amplitude. Of course, always will be some difference. This is real. So for this reason, why there is have just blue, because there is no environment reflection. There is nothing like this noise. There is presence, but you can saw it. So it is this values. This I need to skip because not work in my PC. How is slow? And from second one, you could try same. There you have even video, so it should be probably tweaking. And if you will do it, it is different, -10 degree and 12. But do you see that our model workings relatively precisely? You can definitely evaluate if it is not exactly same, never will be, but the behavior, like description of phenomena is same, and it is enough. Okay, you want higher fidelity with reality, just place reflection from environment, model this, add this to function. It will be complicated, it will be numerically more demanding, but it will be better. Of course, I agree, but it is depends. Do you need this reflection from environment? No, because you are looking for this phenomena, how mitigate it. So if you could recognize the same phenomena on model and on real, and results are same, and of course it is, how you can see, it is from same setting, same distance, same everything. For this it is from metadata, we just put to simulator, then you get relatively similar results. From point of view phenomena, I think that are almost same. Sometimes you need to tweak just, how to say, level of power. But what is this level of power? It is this attenuation. It is just this constant. Okay, and if I will get this in different color, then this result are same. It is just visualization layer of, it is also not so big problem, because if you remember from yesterday, attenuation was one constant, only one divided attenuation, so it was constant. You always can find it, and we already found it to be same. So one tip blade, second tip blade, third tip blade, 120 degrees between harmonic waves and flashes. Exact same. And from my side it is done. And before we end, just wait, I want to show you that there is more. I show you only 2 data, but if you will open tutorial 3, there you have comparison Kamen and Protivanov. But if you will open, okay, I don't put it. I will send you more original data that you can just check for you. I will send you link later, so you can compare even some data that you don't know what is speed, what is initialization angle, and so on and so you can play with it. So if you have any question, just let me know. If not, we will continue tomorrow with last day, and it will be just about mitigation. And again, today I will or tomorrow morning I will share all these scripts for you and everything. Just expect little maths more, because there will be about this mitigation techniques, about Kalman filtering, and it is little longer, but I will speed up to don't get any delay. Okay, so thank you very much for attention, and see you tomorrow at 10.